Okay, so this is step support assignment number 21. It was about sketching graphs with mod functions in them. Now, I don't find mods very easy, so I'm going to do a couple of examples first that are easier than these, and I'm also going to talk about what this is. Now, lots of people think about the mod function as just being, oh, well, it's just a positive. Like, you just take the positive. Whatever it is, you just do the positive. And that's fine, but let's just formalize and come up with a rule for what we're actually doing here. So this is kind of the rule as a formal definition. If you put in a positive or zero number, then you take the positive. Right? So if you put in a 5, you just take the 5. If you put in a negative, you take the minus of your input. So like if you put in a -2, you do minus -2, which of course two negatives make you your +2. So in words, if you put in a positive or zero number, you leave the thing alone. If you put in a 5, you leave it alone. If you put in a 7, you leave it alone. If you put in a negative number, you multiply it by -1. So if you put in a -3, you multiply by that by -1 to get +3. Or -5, times it by -1 to get +5. So those are going to be our rules, and I'm going to be saying that kind of thing a lot. Okay, let's do a simple example then. So the first thing I can see when I try and sketch this graph is that y is always positive, because this is always positive. So I'm not going to be sketching anything down here, because that's where y is negative. Now in this area, where x is positive, the mod function does nothing. Like I just said, the mod function does nothing when you put in a positive number. So over here, where x is positive, this is just y equals x. And I draw that, right? But I don't draw it, I stop here, because it's only in the positive area of x that I'm going to be doing this line. Over here, x is negative. And when you put in a negative into here, you times by -1. So when you put in a negative, you times by -1, and you have to draw this graph instead, right? Because, like I said, when you put in like a -2, you times it by -1 to make a +2, and that's what this function does. So in here, in this area of the graph where x is negative, this is the function I want to draw, right? Which looks like this, and that's my drawing. Let's do a couple more slightly complicated ones, and then we'll do the step questions. So here, the first thing I notice is that this is always positive, or 0. Adding 1 means that y is always greater or equal to 1, because the lowest this can be is 0. Now that's kind of useful to know, because when I have a sketch with my x and y, that means that if I put in a line at y is equal to 1, this graph is never going to be below this line. Right, so I'm only going to draw stuff up here. It's kind of useful to know. And now over here, where x is positive, if x is positive, I leave this alone. I do nothing. The mod bars do nothing. So, and if x is negative, which is over here, then this becomes, I multiply this by -1, and this becomes a -x. So over here, and above this line, I guess, because nothing's going to go below it, over here, x is just an x, and I'm just drawing this line here. And now that has a y-intercept of 1, which is there, so it's just going to be a line like this. Now over here, x is negative, which means I'm not going to be drawing this function here. I'm going to be drawing y equals -x plus 1, because I've just times that by -1, because that's what the mod function does when you put in a negative. And now that again has a y-intercept of 1, and that's a gradient of minus, so it goes this way, so it's going to look like that. Okay, what about this one? Now the first thing I can say is that y is always positive, because this is always positive, which means if I have my sketch, I'm not going to be drawing anything down here. It's only going to be up here. Now, what I need to say is, if x plus 2 is greater than 0, and now the reason I'm taking x plus 2 and not just x is because I'm looking for the entire thing within the mod function. I'm wondering whether that whole thing is positive or negative, because that's going to change whether or not the function does anything. So if x plus 2 is positive, which happens when x is greater than -2, I'm going to leave this alone. Like, the mod bars won't do anything. Now, if x plus 2 is negative, that's when the modulus function times it by -1. And that happens when x is less than -2, clearly, just by rearranging, and I multiply this by -1. Right? So what does that look like for the actual sketch? Well, the critical line is x equals -2, right? The change between these two. When x is bigger than -2 on this side, I'm going to do nothing to this. I'm just going to take it as it is. And when x is less than -2, which is over on this side, I'm going to times all of this by -1, just like I did over here. And it's going to be times the entire thing. Notice the 1 didn't times by -1 here, but that's because it was outside the mod. In this case, the entire thing is going to be times by -1. So anyway, over here, just sketching this graph, the y-intercept is 2. and this graph looks a bit like this. Over here, times the entire thing by -1, because that whole thing is negative now, over on this side of the line. And you end up trying to draw this graph, again, times the whole thing by -1. Y-intercept of -2 would be down here somewhere, but I'm not sketching it over here because that's to the wrong side of the line. I'm only sketching over here. So it ends up looking like this. Okay, so let's get into the actual step question then. So the first thing I notice is this is not an equals to line. So what I'm going to do is I'm just going to make an equals sign. I'm going to put all the things down that make this happen, and then I'm going to test some areas to know where to shade later. And that will make sense when I get there, I think. Okay, so what about this? And let's get the axis down. And now I've got 4 quadrants here. In this quadrant, x is positive and y is positive. Now, if x and y are positive, these bars may as well not exist, because again, the bars don't do anything when the values are positive. So over here, where x is positive and y is positive, I just have the graph x plus y equals 1, because the bars don't do anything when they're positive. Rearrange, and this is a line with y-intercept of 1 and a gradient of -1, so it looks a bit like that. And that's the point 0, 1, that's the point 1, 0. Because when you put x is 0 in, you get y is 1. When you put x is 1 in, you get y is 0. Okay, what about down here now? Well, here, x is positive, so I'm not going to do anything to x. These bars won't do anything at all. But y is negative, so this is going to become a negative y. So I'm going to have to sketch this graph, which rearranged is this. Now, this is a graph or a line with y-intercept of -1 and a gradient of 1. So it's going to look a bit like that. Now, what about up here? Now, up here, x is negative, but y is positive. So this one's going to change, but this one's going to stay the same. So I'm going to have this graph, which rearranged as this. Y-intercept of 1, gradient of 1, looks a bit like that. And that point is -1, 0. And lastly, probably see where I'm going with this. Down here, x is negative and y is negative. It's the quadrant where both are negative, which means both of these will change because the mod function will times both of them by -1. Which means I get this function rearranged as this function, which will complete my square nicely. And now, you probably see what I mean when I said this will be clear later. This is the graph equals 1. So these are the lines where this mod function added together equals 1. But I want to sketch the subsets less than or equal to 1. Essentially, I want to shade the area less than or equal to 1. Now, I think it's probably clearly obvious that it's going to be inside the square here, but let's just be really clear and thorough and check. If I just pick 0, 0, putting in 0 into here, I think does make something less than or equal to 1. So this is a point within my shaded region, and these lines define the boundaries of any shaded region, which means this is the area I shade. Excellent, let's look at question number 2 then. So this is going to be fairly similar. I'm going to make that an equals to, and I'm going to test the areas later. Now, I've colored this blue and this red because I need to focus in on the stuff in the mod sign now. If, there's my graph axis by the way, if x minus 1 is bigger than 0, which happens when x is bigger than 1, then there's no change to this thing in here because it's positive. Right, so there's no change to this. Now, if that thing is less than 0, which happens when x is less than 1, then I'm going to times all of this by -1 because that's what the mod function does when you have something that's less than 1 inside of it. Which means I'm going to times that by -1, which flips the signs. Right? And now I can put down like a critical line of x equals 1 because that's when, over on this side of the critical line, I'm going to not do anything to this. And over on this side, I'm going to times this by -1. So this line represents where I'm going to change my behavior towards this mod function. And now I'm going to make exactly the same argument with this one. And notice how this is exactly the same, just with a y instead of an x. Like everything I'm about to type is the same, just with a y instead of an x. So it's the same argument, exactly the same argument. Now, here I have a critical line of y equals 1, which is this one here. And now above that line, I'm not going to do anything to this because it's positive. Below that line, I'm going to multiply it by 1 in the same way because it's negative. And now my 4 quadrants, you can kind of ignore the axis at this point. My 4 quadrants are defined by the critical lines. This quadrant, this quadrant, this quadrant, and all of this quadrant, which includes these areas here, because the axes don't really mean anything. Now over here, both x minus y1 and y minus 1 are positive, because they're above and to the right of the critical lines, which means I don't do anything to these. I just leave them like this. And now, when you have a mod sign like this, you could maybe change it for a bracket when you're doing this. It's not going to make a difference in this case. It might do in the next one. Okay, so I just rearrange that to make me be able, you can pause the video and rearrange any of these if you want to, but that's got a y-intercept of 3 and a gradient of -1. Now, the y-intercept of 3 doesn't really matter because I'm not sketching this beyond this little area here, right? So it ends up looking like this, with this point being 1, 2, when x is 1, y is 2, and this point when y is 1, I think x becomes 2, and I end up with that line there. Now, what about in this quadrant? Well, this is the area where x -1 is still positive, so I don't do anything to it, but my y -1 below its line is negative. So I change that to a -y plus 1. So the new graph I'm sketching is x -1, didn't change that, plus -y plus 1. Now rearrange that for a line, y-intercept of -1, which is down here, but I'm not going to sketch anything down here, gradient of 1, and I think it looks a bit like this. It goes through 2, 1, I think. 2 minus 1 is 1, perfect. And this point here where x is 1, y is going to be 0. Now what about this quadrant? You can probably see where this is going. This is the quadrant where x -1 is negative, so I flip that one over, but y -1 is positive, so I do nothing to it. Rearrange, draw the line in. That point, I think when y is 1, x must be 0. Excellent, and lastly, this is the quadrant where both were negative, right? So this is the quadrant where I flip both of these over. So I'm going to flip both of those over to get -x plus 1 plus -y plus 1, rearrange. This is a graph, this is a line with y-intercept of 1, gradient negative, so it's going like this. And just check it goes through those 2 points. When x is 0, y is 1. When x is 1, y is 0, perfect. So this is my sketch. And again, this is the sketch of when it equals. I want the sketch of when it's less than or equal to 1. So what I'm going to do is I'm just going to test the most obvious point I can, which I think is this one, which is the point 1, 1, I think. So let's just test 1, 1. Does it do this? Yeah, it does. 0 is less than or equal to 1, so this is the area I want to shade, not the outside. I want to shade this region here. Now, it should be noted that the mark scheme did not do it like that. The mark scheme said, look, guys, you just drew this one in the first example. This one here is just a transformation. It's just this one moved, this -1 moves it 1 to the right, this -1 moves it 1 up, and so you end up moving it 1 to the right, moving it 1 up, and you end up with the thing I had here. Now, the reason I didn't do this is because I don't really want to explain why this moves it to the right, even though it's a negative, and this moves it up 1, even though it's negative, and just to get around explaining that, I did it my way. But sure, if you're happy with this, you can do it like this. Next one. Now, it's super easy to look at this and think, well, this is basically just the same as what I did here. Like, looks pretty much the same to me. Just 2 mods and less than or equal to 1. Great. Now, the problem with this is you need to be a bit paranoid when you do STEP, because this isn't, you're not in one of my year 9 mixed stability maths classrooms, right? Like, STEP is serious. You're not going to get 10 questions that are all basically the same, just with different numbers. STEP doesn't work like that. It challenges you every time. So there is a difference to this question than the one that I just did. And the difference is the sign in the middle, right? And that's going to make it very weird. Because what's going to happen is, if I try to sketch the graph equal to 1, which is what I always want to do, if I try to sketch this, let's just notice, if I shuffle this around a bit, move this to one side and this to the other. Now this over here is always positive. Or 0. It's either positive or 0. Which means this over here is always positive or 0. Positive or 0. Which means when I add 1 to both sides, x -1 mod is always greater or equal to 1. Now, this is a little bit of an issue because that means there are some values for x which I can't have. For example, if I use x as 1, 1 minus 1 is 0, which isn't greater or equal to 1. So I can't put in x as 0 here. So I can't put in x as 0 into here. So when I'm doing this sketch, I'm not going to be able to sketch anything around x as 0. And now, so what values can I sketch? Well, if x is bigger than 2, this is going to work. Like if it's 2 minus 1, that's 1, which is fine. If it's 5 minus 1, that's definitely fine. So if x is bigger than 2, it's going to work. Or if you go into the negatives, like if you use -1, you get -1 minus 1 is -2, modded is 2, which is fine. So these are the areas that I can sketch. I can't put anything in between 0 and 2. So okay, as soon as I've figured that out, then this gets a bit better. So now I can try and sketch this, but remember I can't do it in between those 2 points because then this just doesn't work. So if I put down the graph and then put down a line at x equals 2 and a line at x equals 0, which is just the y-axis, this area in here, I can't put anything in there. Right? Like I can't use any x values here because then this just doesn't work, which I showed in the previous slide. So I can't put anything in here. So I'm only focused on what happens over here and over here. And now I can just do the thing that I did before, right? So if x minus 1 is greater than 0, which happens when x is greater than 1, then this doesn't change, right? And I just keep it. Now if x minus 1 is less than 0, which happens when x is less than 1, then I flip this thing over. And it becomes minus x plus 1. Now, last time I drew a critical value at x equals 1, but I'm not going to this time because that's in the region that I know I can't put anything anyway. So all I'm going to do is I'm going to make no change to this over in this area, and I'm going to change it over in this area. And of course, in the middle, I'm just going to do nothing. Now, what about for the y? Well, if y plus 1 is greater than 0, which happens when y is greater than minus 1, I'm not going to do anything to it. And if y plus 1 is less than 0, which happens when y is less than minus 1, then I'm going to times it by minus 1 and flip it. Times the whole thing by minus 1, remember. So my critical line for y is that y is minus 1. That's when my behavior towards this function changes. Above the line, I don't change it. Below the line, I change this. And now I have my 4 quadrants. I have the axis again, kind of ignore the axis. I have this quadrant. I have this small one down here. I have this one down here. And I have this one up here. But remember, nothing is going in here. Okay, so let's do the first quadrant then. And that's the line minus 1. Up here, so above this line, to the right of this blue line, up here, both of them are positive. So I'm just going to use this. Now this is where the brackets come in handy that I talked about earlier, because this is still going to be a minus 1 here. Right, so it's not just minus y plus 1, it's minus into y plus 1. So if you rearrange that, you get that. Pause the video to do any of this rearranging. I'm not going to spend any time on it. So when I draw that line, the y-intercept should be down here somewhere, but remember I can't draw it beyond this line here. It ends up looking like this. When y is minus 1, x ends up equaling 2. So it ends up being around here. So that's my first line there. Now for this tiny quadrant down here, this is where x minus 1 is still positive, but this is negative. So I times this by minus 1 to give myself minus y minus 1. Now, when I put this into here, when I put minus 1 minus y minus 1 into this negative ends up cancelling them both, and I end up with positives again. So just check that yourself, make sure you've caught up with that. When you put in these negatives into here, and then take them away, you end up with positives. Rearrange, and now that line looks a bit like this. Gradient of negative 1, y-intercept would be up at 1 somewhere, but it's not. And I can only draw it up to 2 anyway, but it definitely goes to the point 2 minus 1, I think. So yeah, it meets this line here. Okay, what about over here then? So ignore the region of nope. What about over here? Here, x minus 1 is negative, so I'm going to flip that. But I'm going to keep my y plus 1 because it's above the line. So I put that in, but remember this becomes a negative still because just like here, I expand out that negative sign, so this becomes a negative. So sometimes I'll use the brackets, sometimes I'll be lazy. Apologies for that. Tidy this up, and then draw this line onto your graph, which looks a bit like this. I had a feeling it would go through here, but you can verify that because when y is minus 1, x is going to be 0, which is on the axis that I had before, on the y-axis, which is obscured by this line, I guess. Okay, down here, in this little region down here, just below this line and to the left of this line, both of them are negative, which means I'm actually drawing this line where I put the negative in for here and then take away all the negatives, which give me positives. I'm going to draw this line. That's a positive gradient, y-intercept of minus 1, which is just going to be that line there. So this is what my graph looks like, which looks a bit weird. Remember, these are just the values that equal 1. Where is it less than or equal to 1? So where am I shading here? Now, these lines define the boundaries. So there are only a couple of places I can shade, either all of this kind of middle area, or all of this area. Now, which is it? Well, if I test one value, I'm going to test this one here, I think. 1 minus 1. If I put in 1 minus 1 into this, I'm going to get, I think, 0 minus 0, which is definitely less than or equal to 1. So that's in the shaded region, which means the shaded region is all of this stuff. Okay, excellent. Let's do the last one then. Sketch this here. Okay, so I'm going to proceed as I just did. So I'm going to say if x is, I'm going to do the equals one first, just like before. If x is greater than 0, I don't do anything. If x is less than 0, I change this to a minus x, just like I've done before. Now the same thing with here. If y minus 2 is greater than 0, which happens when y is greater than 2, then I leave it. If y minus 2 is less than 0, which happens when y is less than 2, then I change this to be a minus y plus 2. Okay, and now I'm going to put my sketch down. My key value, my key line here is the y equals 2 line. That's when my behavior towards this bit changes. And now the x line is just going to be the the y axis. Over to this side, I'm just going to use x as normal. Over on this side, I'm going to use minus x. So, okay, this is the first quadrant up here then. This is where x is just x, like I said, because x is positive. And this is just also the positive version. Okay, so let's put those in. Now I'm going to divide both sides by x, and now I'm going to add 2. And now I'm going to wonder, well, what does this graph look like? Well, hopefully from GCSE, we remember that if I lob off that minus 2, this graph looks like this. So when I add 2 to it, this graph is just going to shift 2 up, right? Which is conveniently going to take it to that place there, because this is the line y equals 2. Okay, what about the next quadrant then? So the next quadrant, x is still just x because x is positive, but this y minus 2 becomes a minus y plus 2 because that's below this line here. So that's in this region here. So put those in, so the x just stays as the x, but this becomes a minus y plus 2. Divide by x, do a bit of rearranging, and I think you end up with this. Now, what does that look like? Now, we get the impression it's going to look pretty similar to this. Let's be careful. So this graph looks like this. What if I put a minus in front of the x? Where does it flip if I put a minus in front of the x? Well, it flips in the y-axis, right? So I think y equals minus 1 over x is going to look like this. Now, this is almost that, except this is just exactly what this is, but added 2. I've moved it up 2. So I'm going to draw this graph, and remember, I'm only drawing it to the right of the y-axis because this is just this quadrant here. So I'm going to shift this curve up by 2, and it slots in nicely here. Just shift it up by 2 because this is a plus 2 here. Okay, and now let's move on to this quadrant. This is where x becomes minus x because I'm in the negative x values now. But y minus 2 is just y minus 2 because I'm above this line. So I get this equation here. Divide by x, add 2. And look, actually, this and this is the same graph, right? The 2 is on the other side, but this and this is the same. So I'm just going to be filling in the rest of this graph, which is going to be this graph here. And I think after you've got the first 2 down, it becomes fairly obvious what the rest of it's going to look like, I think. This last quadrant is the last one to go. Both of them are going to flip over, so there's going to be a lot of negatives here. Divide by x, rearrange, and you get this, which again is just the counterpart for this graph, right? So it's this graph that was shifted up by 2, so it's going to fill in this area here. And yeah, now that's equal to 1, so now I need to shade the areas that are less than or equal to 1. Again, probably quite obvious where to go here, but let's be super thorough. Let's put in the point 0, 0, which is actually this point down here, but that's good enough. That's in the region. 0, 0, 0 times 0 minus 2 is 0 times 2, well, modded, I guess, so positive 2. But that's less than or equal to 1. So this is in the region I want, which means this is the entire region I want there. And yeah, so, I mean, apologies for taking my time with that, but I find mod functions quite difficult, so I just wanted to make sure I was as clear as possible with them.